The symbol will be generated on the screen for fixed support. Now we will give the loads here. Go to force on key points, select the key point, click OK. As it is in Y direction, we select Fy. As it is acting in Y direction, minus 5 kilonewton. So minus because it is acting downward, click OK. So symbol will be generated on the screen for point load, and for UDL we have to do pressure. You see diagram here, 5 kilonewton point load and 4 kilonewton per meter as UDL. So this 5 kilonewton is already done. Now we'll give the UDL. Go to the pressure in that on beams box type, and select the box which will cover the element 1. So all the nodes are selected. Click OK. We'll give the load key as 2 because it is acting in a Y direction, and the numerical value for UDL is 4. I is equal to 4 and J is equal to 4. It will take as it is here. As it is uniformly distributed, the starting and ending value for load is same. Click OK. You can see the UDL is generated on screen, and all boundary conditions are assigned. Now we will minimize this load. Go to solution, solve current LS, click OK. Solution is done. So it's very important that solution is done. This window will not come means you have not assigned all the inputs. If it is came, then all inputs are okay. Then next is you see the different results in general purpose procedure. First is the list result, nodal solution, DOP solution, in the Y direction, Y component will see. Click OK. Let's see the different deformations at point 1, 2, 3, and so on. You can see. Now next is a support reaction. That is along the y-axis Fy. Click OK. We'll see the value 17 kilonewton at node 1. Now to see the shear force diagram and bending moment diagram, we will go to the element table, define table, add that last option by sequence num, then SMIC 3, apply. Will come across this error warning. Then you have to type in command prompt that first of all close this all windows, close this, close, then go to command prompt and type here set comma last. Click OK, and again go to define table, add by sequence num SMIC 3, apply. Similarly by sequence num 6, apply. Once again by sequence num 16, apply. Similarly by sequence num 19, apply. Okay. So you can see these 4 values. So why we have taken 3 and 6 and 16, 19? We'll go to help. I already opened the help window. That we'll see what is the different sign conventions, and the directory is saved for Beam 188. If you want to take a moment diagram, you have to select I is equal to 3 and j is equal to 16. So this combination of 3 and 16 can give us the moment about z axis. Now shear force diagram, I is equal to 6 and j is equal to 19. If we take this combination, we will get the shear force diagram along the y. Right. The item is a SMISE. Coming back to our problem, we have added these all four entities here. We will close this window. So to see the actual, we go contour plot, line element rest, then we'll select the combination for the bending moment diagram 3 and 16. Click OK. So here is the bending moment diagram around the z-axis. You can see the minimum is minus 14 and maximum is 0. These are the approximate values. So near about 43 to 0. So you can see by analytical method here in this diagram. So bending moment diagram, maximum it is 43 and minimum it is 0. Shear force it is 17 and 5. To see the shear force diagram, you have to select again line element rest and select the combination of 6 and 19. Click OK. So here you can see the shear force diagram. So blue color, the value is near about 17 kilonewton in showing by blue band, and red band it is near about 5 kilonewton. Okay, go to plot control, capture image, and you can save this diagram file and save as. Close this. So to see the deformation in y direction, go to nodal solution, DOF solution, y component of displacement, click OK. You can see maximum to minimum displacement. Maximum will be at free end, that is minus 0.24954 meter, and it will be 0 at the fixed end, approximately it is 0. If you want to see the beam with cross section, that is 3 dimension, and go to plot control, in that style, size and shape, and switch on the display of element, click OK. You can see the 3-dimensional beam. Go to isometric view. Now if you want to see the animation from the actual size to deform size, go to plot control, animate, go to deform shapes, then click OK. So that beam will animate between original position to variable position. You can vary the speed from 1 to 10. Accordingly, the animation will appear. So hope you can solve any similar problems on a beam. So we will end this video. Thank you so much.